So we're talking about optimization problems today, which is really just you're finding either absolute maximum or minimums or relative maximum or minimums, just with context to the problem. So they're word problems, find a max or a min. Okay. First problem says a manufacturer wants to design an open box having a square base and a surface area of 108 square inches. What dimensions will produce a box with the maximum volume? So for all of these problems, you should have two equations that you can set up. One of the equations will have two unknowns, and the other one might have some unknowns, but we can isolate a variable. So I'm trying to maximize volume. I like to write a note to myself that it's not just volume, it's max volume, because that helps me to remember I'm going to need to take the derivative of this function at some point. All right, so what do I know about volume? I'm not given a numerical value, but I know in general, volume of a box would be length times width times height. Remember, it has a square base, so you can see in this picture, that would be x squared times h. Now, in the equation that you're taking, that you're going to be trying to maximize, in other words, the equation that you're going to be taking the derivative of, you don't want to have two variables because that means you're going to be using some sort of product rule and you might not have all of that information. So they did give you surface area information. All right, so I know that we have a surface area of 108 square inches. I'm just going to say S for surface area before I sub in a number here. Surface area would be, you have to think about all of your surfaces. You have, let's see. Oh, okay. It's an open box. So I was about to say you have two surfaces that are x squared, but it's open, so there's no surface right here. So there's just an x squared base. And then around the sides, we have x by h and x by h. So even though this doesn't look like a square base, you have four x by h rectangles going around the sides. We are told that surface area is 108, so go ahead and sub that in. All right, and we want to know what dimensions will produce a box with maximum volume. So it would be easier in the surface area equation to isolate the h, so I don't have any factoring or craziness going on. So I'm going to solve this for h and then replace the h in the volume equation so that the volume equation will now all be in terms of x. All right, so isolate the h. So that would be 108 minus x squared, and you're going to divide all of that by 4x. That's what h would equal in the surface area equation. And now I can use substitution to go back to my volume equation, which is what I really need to be working on. And I can sub all of that in. X squared times 108 minus x squared over 4x. And you should simplify. Now remember, well, sorry, let me simplify first by saying I would have this x squared, one of these x's cancels with this x down here. So start there, and then I would probably go ahead and simplify this and say like 108x divided by 4. Let's see, does 4 go into that? Yeah, twice, 28, 7, so 27x, 108 divided by 4 is 27x. And then x times x squared is minus x cubed. This is still over 4. Because I divided 108 by 4, I still have to divide the second term by 4. And at this point, I have an equation that's all in terms of x's. I can go ahead and take the derivative. So this would be I'm not just going to write v prime for this one. You can, but I'm taking the derivative with respect to x. There's nothing in this problem about time, so don't switch back to like dv dt because we don't have any like rate of change things going on. So I want to take the derivative of the volume so that I can find points at which that derivative changes. So 27, and then it would be minus 3x squared over 4. And then I want to find the critical numbers for the volume. So if I set my derivative equation equal to 0, I can add 3x squared over 4 to this side, multiply the 4 back over. So maybe I didn't need to divide it out right away, either way. Then I'm going to divide by 3. I'm gonna bring this work up here. So I'm getting x squared to equal 36. Now, could x really be plus or minus 6? This is where you have to think about domain. We can only have x values greater than 0. X can't be 0 because then you don't have a box, and it can't be negative. So not really plus or minus, just 6 for x. And then remember, we're looking at putting our critical numbers on a number line and looking at what's happening at v prime and what does that mean about the volume itself. So if I put 6 on here, again, remember our domain is really, you don't want to plug 0 in because you can't have that for x. So our domain kind of is restricted on that side. So if I plug in something like 5 into the derivative equation, 27 minus, let's see, 20, I should probably write this down. 27 minus 3 times 25, so minus 75 divided by 4, though. 75 divided by 4 is something in the teens, right? Because 4 goes into 7 once, and then you'll get 35. And so, yeah, so it's definitely not 27, okay? So 27 minus something smaller is negative. And then if I plug in something to the right of 6, like 7, if I plug in 7, I get 27 minus 3 times 49 over 4. 3 times 49 divided by 4 is going to be 27 minus something bigger than 27. Oh, sorry, I wrote a negative sign. Positive on the left, that's going to come out negative on the right. What does that mean about the volume? It means it's increasing and then it's decreasing. So back to the question. What dimensions will produce a box with the maximum volume? The maximum volume happens when x is 6. So max volume. They didn't ask us to find the maximum volume, so I'm not going to. But if we needed to, we would plug 6 back into our volume equation, and we could figure out what the height is too. But I'm going to say max volume when x equals 6 inches and h equals, what is h when x is 6? We can go back to our equation over here and our surface area equation and figure that out. 108 minus x is 6, so minus 36 over 4 times 6 is 24. So 108 minus 36 is 72 over 24. That's 3. So the max volume is when x is 6 inches and h is 3 inches. And I was just thinking about, yeah, would I have to justify this? It probably wouldn't hurt, to be honest. Remember, the AP grader is still not looking at your number line at all. You're probably getting a point for having a volume equation. You're probably getting a point for having a correct derivative equation, maybe 2 points for that, depending. You're getting a point for your answer. They may or may not need justification with that. So you would just say, because v prime changes from positive to negative at x equals 6. All right, number 2. A rectangular page is to contain 24 square inches of print. The margins at the top and bottom of the page are to be 1.5 inches. So top and bottom, this space is 1.5. And the margins on the left and right are to be 1 inch. 1 inch there, 1 inch there. What should the dimensions of the page be so that the least amount of paper is used? This Y is referring, and the X, those are the dimensions of the actual print here. And the reason they gave you the margins is so that you can come up with dimensions for the outer piece of paper, the size of the paper. So the vertical length of the paper is the print size Y plus 1.5 inches on top plus another 1.5 inches on the bottom, so Y plus 3. And then the width of the paper is the print size X, however far that goes, plus 1 inch on either side, so plus 2. So we're trying to have the least amount of paper. So we want a minimum paper size or paper area. And we also have a print area. The minimum paper area, I'm just going to say A equals minimum paper, or just paper area, excuse me, in general, would be X plus 2 times Y plus 3. We don't want to have two dimensions. It would be better to come up with our print area. So I'm going to say area, I don't know, sub P for print. That would just equal whatever X times Y is. And then we are told that the rectangular page is supposed to contain 24 square inches of print. So we know that that is supposed to be 24 equals X times Y. And it doesn't matter whether you solve this for X or Y. They're both equally easy to solve for. I tend to solve things for Y for some reason. So I would take 24 divided by X and make that equal to Y. And then I would sub that value in for Y into my area equation. Okay, so now I have area is equal to X plus 2 times 24 over X plus 3. So now your area equation that you're going to be taking the derivative of, it has one variable. We could do product rule on this, or we could also just go ahead and FOIL this out. I think I kind of like the idea of FOILing it out. X times 24 over X is 24 plus 3X plus 48 over X plus 6. 24 plus 6 is 30 plus 3X plus 48 over X. So right now I have, this is my area formula, and then that's better to me than product rule. I can just take the derivative of each term. So the derivative of A with respect to X, again, not with respect to time, that's only related rates when they're giving you speeds and velocities and things. So the derivative of the constant is 0. Derivative of 3x is 3. This is 48 times x to the negative first, so minus 48 over x squared. And remember, anytime you have a variable in your denominator, it's a good idea to go ahead and get a common denominator, make it 3x squared minus 48 over x squared, so that you consider places where your derivative is equal to 0 and undefined. So critical numbers. 0 equals 3x squared minus 48. I can factor out a 3, or I can isolate, whatever. You should be able to get to x equals plus or minus 4. Are those values within the original domain? If we're talking about the original domain, like what are possible values for print size? X can't be 0 and it can't be negative. So plus or minus 4 is no good. Just 4 for the critical number. And then for the denominator, again, I should show that I'm considering this. X squared equals 0, but again, X can't be 0 for a print size. We have to have some print on the paper because it says you need 24 square inches of print. So when it comes to plotting my critical numbers, I like to, if I have a restricted domain, we're talking about X here, I like to remind myself that I can't be plugging in 0 or anything negative, but I am going to plot 4 on here. Okay. Let's see. So we're talking about area prime and area. So if I just plug in 3 into the derivative equation, I'm looking at right here. If I plug in 3, I get 3 times 9 minus 48 over x squared is always positive, although it's not hard to show yourself that that's 9. 27 minus 48 is negative, divided by 9 is still negative. And if I plug in 5, 3 times 25 minus 48. 75 minus 48 is positive, divided by positive is overall positive. So the area decreases and then increases. That shows me that there is a relative min at 4. And the question says, what should the dimensions of the page be so that the least amount of paper is used? It doesn't ask us what that smallest area is, so we don't have to spend time plugging it in. But I would say the minimum paper area occurs when x equals 4. Are we talking about inches? Yep, 4 inches. And you need to say what y would be too. Remember, if we know x back here, y was 24 divided by x. So it occurs when x equals 4 inches and y equals 6 inches. The reverse is not part of our answer. I can't say or when x is 6 and y is 4, because remember the top and bottom margins are different than the left and right margins, so that it does matter what x is and what y is. And again, I can say because a prime changed from negative to positive at x equals 4. The process for all of these problems is the same. The only thing that changes is what equations you start off with. So for number 3, it says, which points on the graph of y equals 4 minus x squared are closest to the point 0, 2? It helps to visualize this one. Let's think about the graph. 4 minus x squared, so that's 4, right? Minus x squared means it's a parabola that opens down, and I know these zeros are happening at 2 and negative 2. Which points on this parabola are closest to the point 0, 2? So here's 0, 2. Which points are closest? Closest should be points that are perpendicular, right? So we're basically saying like, whatever this point is, well, what do I mean by perpendicular? Sorry, excuse me. Perpendicular at the point of tangency. Okay, so that's this point, and there should be another point. My drawing is kind of poor, but there should be another point on the other side for which we have a closest point. So what are we trying to do? Closest means minimum distance, right? And yeah, if I want the distance between 2 points, I can use the distance formula. So I want to minimize the distance. And what else did they give me? They actually gave you the equation to use. The other equation that you're using isn't, I don't really have a description for it. It's not like it's surface area or something. It's just I'm given y equals 4 minus x squared. So think about the distance formula, the distance between 2 points. Well, it's the distance between any xy on that curve and the point 0, 2. So first, the distance formula is x minus 0 squared plus y minus 2 squared. But again, we don't want x's and y's. We have a second equation that says, hey, y in terms of x is 4 minus x squared. So you can sub that in for that y right there. So now the distance formula is square root of, how about we just say x squared instead of x minus 0. And then this is going to be, because I don't want to have to write this all over again, y minus 2 is going to be 4 minus x squared minus 2 squared. That's 2 minus x squared squared, okay? I just didn't want to write 2 separate lines for that. And then I should keep working on this. Don't commit a terrible algebra mistake. You're not allowed to square root each part and make it x plus 2 minus x squared. No, you have to FOIL out what you have. So this would become 4 minus 4x squared plus x to the 4th. So what do we have here? We have x to the 4th minus 3x squared plus 4. So here's my distance equation at this point. Now I need to take the derivative of that. Ought to be fun, right? So the derivative, you know, I am going to write d for this one because I don't like when I have dd. dd dx. You can do that though. Okay, this is a chain rule one, right? Because we have square root of something. So first of all, that's 1/2 times the thing, all of this, to the negative 1/2 power. So 1/2 times x to the 4th minus 3x squared plus 4 to the negative 1/2 power. And then don't forget to chain rule. You have this inner function. So the derivative of the inner function is 4x cubed minus 6x. Okay, so I'm noticing this. 4x squared minus 6x could have had a 2 factored out of it. Oh, correctly, hopefully. This 1/2 times this 2 could cancel out. So I would have a 2x cubed minus 3x in the numerator. That's after I factored the 2 out and divided it by 2. And then I do have a denominator, but it's just the square root of x to the 4th minus 3x squared plus 4. All right, so I'm going to bring my critical numbers way up here. I can set the numerator equal to 0 and start factoring it as well. I can take an x out, and that gives me 2x squared minus 3. Okay, so we get x equals 0. We get x squared equals 3 over 2. X can be plus or minus square root of 3 over square root of 2. Do we have to rationalize that? It doesn't matter. So I guess I'm going to, but you don't have to. I was trying to think of like what would be easier to plug back in, but I just won't worry about that at this point. Are all of these values okay to plug into the original curve? Yes, because there are no domain restrictions on the graph of 4 minus x squared. So all of these are candidates here. And okay, and then we still need to set our denominator equal to 0. Square root of x to the 4th minus 3x squared plus 4. Now you can square both sides, so that's gone. We can factor x squared minus, oh no, wait, can we factor? No. I almost factored it into minus 4 and plus 1, but you have to multiply to positive 4 here. So I have a feeling that this is never going to be negative. How would I know for sure? You can do quadratic formula. We wouldn't normally say to do this. Yeah, I mean, if this were a calculator problem, I'd just look on my calculator. But you can say like x squared would equal 3 plus or minus the square root of 9 minus 4 times 1 times 4 all over 2. X squared would equal 3 plus or minus something imaginary over 2. So yeah, that's not going to be possible. So you can kind of say like, oh, never 0. All right, so we don't get any critical numbers from the denominator because it's square root of something that's always positive. Okay, back to our critical numbers that we do have, though. We have a negative radical 6 over 2. We have a 0, and we have a positive radical 6 over 2. And we're talking about d prime and what's happening with d. Negative square root of 6 over 2. What's something more negative than that? Oh, I don't know, negative 3, negative 4. If you're not quite sure, just go a little bit further down, but I'm just going to plug in negative 3. Okay, so if I plug in negative 3 back into, where did my equation go? Remember, here it is. Remember, the denominator is always positive. So you're plugging negative 3 and getting 2 times negative 27 over something positive. So that is negative overall. And if I plug in like negative 1, in between here, you're getting -2. Oh, sorry, I did forget part of this. It doesn't change my outcome. 2 times -27, sorry, plus 9 is still negative on top. I forgot this minus 3x here. If I plug in -1, I get -2 and then plus 3 over something positive, so that's positive overall. If I plug in 1, I get 2 minus 3 over a positive, which is negative. And if I plug in like something bigger, like 3, I get 3 times positive 27 minus 9 over something positive. That's positive. So the distance graph decreases, then increases, then decreases, then increases. And the question is, at which points are we closest, or where is the minimum distance to the point 0, 2? So there are two minimums, which kind of matches what my graph said, right? There are two minimums at plus or minus square root of 6 over 2. So this point must have been positive square root of 6 over 2, and then whatever y is. And this one should have been negative. Now it does say which points, so I do need to find what the y is. I sort of quickly said, oh yeah, and whatever y is, but I need to actually find that. And I just lost there we go. Remember, it's just 4 minus x squared. So this is where when I was trying to figure out, should I rationalize this? I probably should have left it plus or minus square root of 3/2, because then squaring it's easier. Squaring, you just get 3 over 2. So, wow, I really ran out of room here. So I'm going to do this work up here. Y equals 4 minus, whether you're plugging in plus or minus, when you square the square root of 3 over 2, you get 3 over 2. 8 over 2 minus 3 over 2 is 5 over 2. And again, graphically, you can see, oh yeah, they should have the same y value, just different x values. So I totally ran out of room here, but the minimum points, the minimum distance occurs at these 2 points. And finally, our last problem here. 2 posts, one is 12 feet high and the other is 28 feet high, stand 30 feet apart. This entire distance was 30, so that's why it was broken up into x and 30 minus x. And you could switch. You could make this side 30 minus x and this x. They are to be stayed by 2 wires attached to a single stake, running from ground level to the top of each post. Where should the stake be placed to use the least wire? The wire is the orange section. The minimum amount of wire, I'm going to say W, equals A plus B. And what other equation can we use? Well, we can use Pythagorean theorem. And we actually have 2 triangles, right? We have x squared plus 12 squared equals a squared. So that's nice. And we also have 30 minus x squared plus 28 squared equals b squared. Now, I can't solve for my minimum wire problem because that's what I'm trying to minimize, so I have to take the derivative of that. I need to solve one of these equations for either A or B. I would say it seems like it's going to be easier to isolate A, I guess, because I can just, well, I guess it doesn't matter, does it? Actually, okay, yeah, we can say this. I can solve for both A and B just as easily by square rooting, right? And I know that it's not a plus or minus square root because A and B are distances. So A is greater than 0 and so is B. Okay, so W is actually just the square root of x squared plus 12 squared. I guess we'll make that one 44. And B is just the square root of, we're probably going to need to FOIL this out, don't you think? So 900 minus 60x plus x squared plus, oh, what's 28 squared? Goodness. something like this. Did I get that right? I did, 784. Okay, and we can clean this up a bit more. We're getting a bit obnoxious with our large numbers, and that's okay. X squared minus 60x plus 1684. All right. Now I want to take the derivative of this. 1/2 times x squared plus 144 to the negative 1/2. Chain rule times 2x plus 1/2 times all of this to the negative 1/2 times the derivative of the inner function, 2x minus 60. Oh, oops, minus 60. No, yeah. 2x minus 60. Clean things up a little bit. 1/2 and 2x is just x times x squared plus 144 to the negative 1/2. Plus, now again, factor 2 out so that this 2 multiplies with this 1/2, and that's gone. So you have x squared minus 60x plus 1,684 to the negative 1/2 x times x minus 30. Goodness gracious. Oh, hey, we get to use a calculator on this one. I just saw my note. Okay, so I'm trying to find critical numbers. I'm going to use my calculator. I want to know when this thing is 0 or undefined. So let's see. How do I want to write this? Oh, wait, somewhere in here, should I have a negative? It's 30 minus x. I don't think so. Okay, sorry. I'm just double checking my work here. Okay, so let's see. We want to know, when is this thing equal to 0? Maybe I'll write it like this. I'm trying to figure out how I want to type it into my calculator. So I've got this, and then I've got plus x minus 30 over this thing. I think it's probably, to me, it seems easier to type in with square roots instead of all the parentheses. Okay. So let's do this. Into y equals. Scatter plots off. So I want to know, when is this equal to 0? When is it undefined? Side note, is x squared plus 144 ever going to be 0 or negative? No, so there's no undefined point from there. And x squared minus 60x plus 1,684. I'm going to guess, in interest of time, that this is always positive, but you could verify that by typing it into your calculator and just seeing how it comes out. Like, is it ever hitting the x-axis, or find the vertex of it, whatever. So all I'm interested in is, where does this thing equal 0? X divided by square root of x squared plus 144 plus parentheses x minus 30 divided by square root of x squared minus 60 x plus 1,684. I always do Zoom 6 to begin with, even though I know, especially with some high numbers, that's probably not going to fit. I like to Zoom 6 to reset my window, and then I like to Zoom Fit, which is Zoom 0. And I can see a 0 right here. And then maybe from there I adjust my window. Like, how about we bump the maximum x out to like 50? And we'll bump this y max to be a bit taller, just to make sure. I don't know, put it up to like 2. And then you just hit graph. This is continuing to increase. And I think we're going to be okay to say that I know we're going to be okay to say that there aren't going to be other points, because coming back to this, the maximum value for x, like x can't actually be 30, right? Because if x is 30, then you've placed the stake at one end or the other, and it has to be within this 30-foot distance. Okay, so I can see that the only point, if I find that 0, when I did zoom standard, it looked like it was 9, but now I'm beyond that, so I'm going to have this calculate a 0. You do need to know how to use a calculator to do this for the AP test. Yeah, okay, so that was 9. So the critical number from the calculator comes out, what's happening? Comes out to be x equals 9. And you don't have to test values, because you can see on your graphing calculator, this is the equation for the derivative, right? So you can see, oh, the derivative's negative to the left of 9 and positive to the right. That means that the wire length decreases and then increases. And we want to know, trying to minimize the wire. So where should the stake be placed? Let's be specific about this. Here it's 9, are we talking about feet? Yeah, 9 feet from the 12-foot pole. It's not 9 feet from the 28-foot pole. It's 21 feet from there. So you do need to be a little bit specific. So place stake 9 feet from 12-foot pole for minimum wire length. Okay, so that's it. So again, it's always the same process. The hardest part, besides maybe a crazy derivative, is just making sure you have your 2 equations to go off of, and that you're always manipulating the one that you're not going to take the derivative of.